Thank you so much for being here. We really appreciate it. We're super excited to be here and sharing our presentation. But before we start, we just wanted to say how inspired we were to be here with all of you and to hear your stories. And we're also just super inspired by all the amazing speakers. Are there any speakers in the room? Can we give them a round of applause? So we've learned a ton from all of you and really, really enjoyed being here. So thank you, and thank you for coming to our talk. So welcome to a brewer's guide to filtering out complexity and churn, or as we like to call it, the coffee machine talk. The goal of this talk is to show you how to remove the bitterness that's caused by complexity and churn in your application. There's three things we want to do over the next 30 minutes. We want to show you how complexity sneaks into your application, how you can see it, notify it, like get a handle on it, and then how to remove it permanently. So we're going to introduce ourselves and then we'll get going. I'll go first. Hello again. My name is Alan. I use the pronouns he, him. I've been using Ruby for about a dozen years, and I'm from Seattle originally, so there's coffee in my veins, like it's there. My favorite is a New Orleans cold brew with chicory.
Hi everyone, I'm Fito. I use the pronouns he, him. I also have 12 years of experience in Ruby. I'm from Asunción, Paraguay, South America. Although I'm coming from the San Francisco Bay Area this time. So I have to say, if there's one thing I love as much as Ruby, it's coffee. My favorite is a Ghirardelli dark chocolate mocha. Now, Alan and I work together at a place that you might not expect, given that this is a conference for Ruby developers. We've actually heard this a few times during the conference. We work for Cisco Meraki, and it's the largest rail shop you've never heard of. But also, we've been friends for years, and we've worked together actually at 3 different companies over the last 9 years, and we've seen a wide variety of code bases. Plus, we spend a lot of time on the weekends writing code and drinking coffee. So, Alan, you grew up around coffee, didn't you?
Yeah, I did. And back when I was a kid, nothing fascinated me more than these mechanical coffee machines. They had them in my dad's office. You drop in a coin, you listen for the clink, you make your selection, and then all of a sudden this machine springs to life, hissing and clicking and whirring. And at the end, when the ballet finishes, there's this one last sound, and that's the sound of that glorious aromatic black liquid splashing into the cup. C'est magnifique. These days, I'm a little bit more fascinated by the complexity that you find in software. We both are. And like the coffee machine, there are all kinds of hidden complexity in software. But it doesn't always start out that way, does it? Show of hands, how many of you worked on a greenfield application? Awesome. How did that feel? Yeah, feels great. How about how many of you worked on a legacy application? Even more of you. How did that feel? Yeah. That's been our experience too. You know, greenfield development feels great. It feels fast. There's not any existing code getting in your way. But legacy code always feels harder to work with. Why is that? We believe that it has to do with software complexity. And we think that there's a threshold that a particular application will hit at some point, after which you only have 2 choices. You can either live with the complexity as it grows and development slows down under the impression that it'll somehow magically disappear, or you can pause temporarily and reflect on the design of your software. Then you can reorganize it and speed up development again. Now, we've seen organizations go both directions. When you take that path of living with the complexity, though, engineers, I think you probably all know this, engineers end up frustrated. And in our experience, they sometimes even begin to blame Ruby for the problem, and they'll look for alternative solutions. I don't know if there's any Rust fans in here, but we have Rust people at our office who are constantly trying to push our Ruby code in that direction. It's not Ruby's fault, though. It's the complexity that we ourselves added to the code base. So what we're going to do here today is we're going to show you how to take that second path and remove the complexity from your system so that you can fall back in love with Ruby. So the way we're going to do that is we're going to build a little coffee machine application. Now this application will have several features. We'll add them one by one, and then we're going to go back and look at how complexity snuck into the application and look at each commit, and then finally we'll reorganize the code to show you how to get rid of it. All right, are we ready? All right, let's get started. Who wants to build a coffee machine? Fito?
Let's do it. Yes, let's do it. Okay, so how does complexity sneak into software? The answer, of course, is, Alan already said it, one commit at a time. So we'll take a look at that. Now I'm gonna go through these slides pretty fast, just to show you the shape of the code as it grows. So don't worry about trying to understand exactly what's on the screen. The code is made up anyway. Also, we're skipping tests for the sake of time, but in reality, we would not be doing this without tests. All right, let's get started. Here's the first commit in our coffee machine application. At this point, the coffee machine does one and only one thing. It serves coffee. First, it dispenses a cup, it heats the water, prepares the grounds, dispenses the water, and finally, it disposes of the grounds. Now, this works great, but turns out not everyone likes coffee. So to increase our sales, we are going to add tea. So here, we've added a conditional to determine whether to serve coffee or tea. And in the process of doing that, we added some duplication. The dispense cup, heat water, and dispense water steps are all duplicated between the two beverages. So let's try it out. All right, here's the dry version. And now that we have both coffee and tea in production, we're getting some feedback. Turns out the most requested feature is to add sweetener. So let's go ahead and do that. Oops. Okay, so here we've added the sweetener just after dispensing the hot water. Of course, not everyone likes sugar, so we're gonna make it an optional ingredient. Okay, so we push this out, customers love it, and now they want cream. Let's give it to them. Since we already have a pattern for optional ingredients, let's dispense cream right after we dispense the sugar. People like it, and for our next feature, turns out that some folks don't like coffee or tea. Let's offer them something else, like cocoa. All right, here we follow the existing pattern and added cocoa to the main if statement. But there's no need to add sugar or milk since cocoa is already sweet and creamy. So we're gonna exclude those options when the customer is requesting cocoa. Okay, and finally, who doesn't like whipped cream on their cocoa? Heck, I even like it on my coffee, so let's add it. Okay, so whipped cream is an optional ingredient that no one wants under tea. So let's add it after the other optional ingredients and exclude it when the customer is requesting tea. Okay, so here we are, 7 commits into this code base, and we've already got 9 conditionals in one method. And at this point, it is still relatively simple to understand and work with if you're the only one working on it. Procedural code like this does not scale well for a larger team. And one of the problems is that future developers will just keep adding more conditionals with each new feature. And that's going to cause the complexity to skyrocket. And our little coffee machine has been so successful that we just got purchased by a big national soup chain. They want us to add soup to our coffee machines. That's going to add a lot of complexity. So let's pause here and evaluate where we are before we try adding more features. Alan, can you walk us through it?
Sure thing. So far, we've reached an inflection point in the life of our little application. But how can we tell? What is it that tells us to pause and rethink things? Well, the first hint is that we had to keep reducing the font size to get that thing to fit on one slide. The second hint is, method length is really actually a good indicator of method complexity, even without measuring it. Sandy Metz has a rule about it. Sandy is the author of Practical Object-Oriented Development in Ruby. If you haven't heard her talks, maybe you should go do that. She has a rule about method length, and it can't be longer than 5 lines of code, which might seem really restrictive, but trust us, it's a very important rule. In addition to method length, though, we also look at method complexity. This is a quantitative measurement of how difficult it is to understand a piece of code. Our preferred metric is called assignments, branches, and conditionals. There are others, like cyclomatic complexity and so forth, but this one's our preferred metric. The higher the number, the harder it is to understand. We use a gem called RubyFlog to measure this for us. It also throws in some Ruby-specific things, so it's a good tool for Rubyists. But it gives us this score, and how do we know what to do with it? What's a good score? What's a bad score for a method? So way back in 2008, a gentleman named Jake Scruggs, who wrote the metric food gem, produced this list on his blog, and to this date, it's the only list we can find that says these are the good scores. We've been using these scores for years in our own work, and they really do work. They really do drive you towards simpler software. So how do we think our little coffee machine fared? Why don't we go back through it one commit at a time and look at what the complexity scores were. So our first commit weighs in at a complexity of 5.5. Now, according to Jake, that's awesome. So that churn number there, by the way, is the number of commits that have been made to this file. That'll become important later. Adding the conditional with the duplicated code really shoots up the complexity. At 14.6, we're not in that awesome zone anymore, but we're still in the good enough zone. So we'll keep going. So after we removed that duplication, the complexity actually dropped pretty significantly down to 10.9. Now this may seem like a good thing, but it's actually where things started to go wrong. Notice how we've intermingled the two algorithms. You can no longer really see what it takes to steep tea or to brew coffee. You have to read the whole thing and kind of parse it. It also sets a precedent for how future developers are going to extend this code by adding more conditional logic. From Flog's perspective, though, the math says that the complexity went down. So there's a valuable lesson here. There is no magic metric that will tell you exactly what's going on with your code. There are tools that can inform you, that can help you with your decision making, but it doesn't take away your need to use intuition about these things. So pay attention to how hard it feels to add software as you're going, and if it starts to feel like it's slowing down, that's a good time to pause and reflect. Make sure that you have a good sense of where your design is headed. Next, we added sweetener. That took complexity up to 13.5. Then we added cream, we're at 16.0. We added cocoa, that pushed us over the good enough line of 20. We're at 21.3 now. Let's add the whipped cream just to top things off. Pushes us up to 25.5. Now, if you look at the trend line here, you can see that it's starting to curve upward. That's a good sign that it's time to pause and reflect. Plus, we did cross that Jake's threshold of 20 for good enough. So There you go. 3 ways of recognizing when it's time to pause and reflect. The first, look at the method length. If you can't see it on one screen, probably too complex. Sandy's rule, again, is 5 lines of code. Second, method complexity. You can use a tool like Flog and produce a score, and anything under 20 in Flog is good enough. So just keep going if that's where you are. And then finally, intuition. How does it feel? How are you feeling about the software that you're adding? So that's how we knew we'd reached this inflection point and it was time to start thinking about reorganizing this method. And that's what Fito's about to do right now.
Sounds good. So we broke Sandy's rule, we crossed over Jake's good enough line, and we intermingled 3 algorithms there. So that sounds pretty dire. But is it? Can we turn it around? Yes, absolutely. Let's do it. All right, so here's the method as we left it a moment ago. Now, code that's dried too early can lead us in the wrong direction. So let's start by undrying this code, or add back the duplication to see if there are any missing abstractions that are hiding in plain sight. We call this practice rehydration, and it looks like this. Now, I know what you're thinking. Obviously, this increases duplication, right? But that's what we need to do in order to find these missing abstractions. Now we can clearly see each recipe, and since there's no overlap in the algorithms anymore, we can safely extract each one of these into separate polymorphic classes, like this. Can I give you a moment to look at it? Now, as you can see, we moved each recipe into its own class. 1 for coffee, 1 for tea, and 1 for cocoa. This structure has a couple of big advantages. Each algorithm is now separate from the others. That means that if you should ever need to modify one of them, let's say to fix a bug, or extend it, there's a much lower risk of you introducing a regression in another one of the algorithms. Plus, the when method is now much simpler. Now, you might have noticed that there's duplication between the classes, right? Like class to dispense cup, heat water, and dispense water. Those methods are present in every class now. We actually want that duplication. Let you take a look for a second. It makes understanding the code and the complete algorithms much easier, since you have the whole algorithm for each beverage present in each beverage class. Like, you only need to open one of these files when you're going to look at them. So we do not want to dry up the algorithms per se. Rather, what we want to do is to ensure that there is only one implementation of each of these methods. That's what's meant by don't repeat yourself. It's perfectly okay to call a method multiple times. It is preferable to only implement that method once. Now, Ruby provides multiple options for doing this. We could include a module, we could use composition, or we could introduce inheritance and put the methods, the definition of the methods in a base class. In this case, because we're using polymorphic classes and because we're unlikely to need these methods elsewhere in the application, we would probably go with inheritance. Okay, we're almost done. There's just 2 remaining problems here. First, the when method is not open-close, meaning that you have to modify the code to extend it. Second, it has multiple responsibilities. Let's take a look at the responsibilities first. Its only real responsibility should be to prepare beverages. But right now it's also picking which class to instantiate. And that's the job of a factory. So let's introduce one. Okay, so here we've pulled class instantiation out into a factory class. Its only job is to choose which class to build based on which drink was selected. Now the when method only has the one remaining responsibility, to prepare beverages. And it is now open-closed. That means we'll never have to modify the when method again, when we want to extend the functionality of the coffee machine. The vent method is now set to be open for extension, but closed for modification. However, you might have noticed this. The open-close problem just moved to the factory now. And we introduced another issue here. The build method in the factory might return nil. And that's going to cause the coffee machine's vent method to throw an undefined method error. We can solve that by introducing the null object pattern, like this. As you can see, the factory returns a null beverage now by default. So if we were to get a beverage type that we don't support, just return the null beverage. And this class is just simply a beverage class with a prepare method that does nothing. As for the second problem with the factory, it's still not open-closed, which means every time we're going to add a new beverage, we'll have to modify the factory class and probably the tests that go with it. We can solve that by using a different kind of factory. So here we've replaced the conditional-based factory with one that's based on a convention and a little bit of metaprogramming. The advantage of this approach is that it is mostly open-closed. There might come a day when we'd want to add a class name that doesn't follow our convention, and at that point, we need to modify the convention, which would violate the open-close principle. So for this reason, and because metaprogramming tends to obscure what's happening, we actually tend to consider this kind of factory an anti-pattern. There are alternative approaches that are fully open-closed, and we would love to discuss them offline. We actually really enjoy that topic. So come chat with us later. But for the sake of this talk, let's just stick with our convention-based factory that's mostly open-closed. Okay, at this point, let's take a look at where we are with complexity. And let's start by revisiting this graph that Alan was showing us. Here's where we left off after adding whipped cream. The next thing we did was to hydrate the code. Oof, look at that. That's much more complex than the dry version. But remember, the dry solution was hiding the fact that there were missing abstractions in there. So what we did next was we pulled the algorithms out into their own polymorphic classes, and this dropped complexity significantly. And finally, we extracted the factory object. And now, the complexity is lower than it's ever been. We are now well back in the awesome range. And the vent method will never need to change again. Now, let's take a look at all the other classes we introduced in the process of refactoring this. There are 6. Coffee machine has now settled down to a very low complexity of 3.9. The factory is next at 6.2. And then we have the 3 beverages that are a little bit more complex, but well within the good enough zone. So there's nothing really more to do with them. And that's where the meat of our logic lives, so it's okay. And the null beverage doesn't do anything, therefore 0 complexity. Except that there was a reason why we did all this, right? We needed to add soup to our coffee machine. And we wanted to do so without making it more complex. So here's where we left off. Let's add some soup. There you go. Adding soup did not require us to change any of the existing files. It just works. As long as the soup class is loading into memory, it will be available for the factory to instantiate. And in the future, adding another beverage will be as simple as adding another class and the tests that go along with it. So that's it. That's a look at a very small greenfield application, though. And I know what you're thinking. Your applications are obviously a whole lot bigger and a whole lot more complex. So how will you know where to start when you get back to work? You got any ideas?
Glad you asked. So far, we've really only talked about method complexity and how watching it as the method changes over time will help you prevent complexity from sneaking into your application and becoming painful. But you can also use complexity with churn, that number that was also up there, to find problems across your entire code base. So as we mentioned, complexity is the measurement of how hard it is to understand a piece of code. Churn is the measurement of how many times that code has changed. The way we like to think of it is complexity represents the amount of pain you're going to experience the next time you work in that object. And churn represents how often you're inflicting that pain on yourself. So if there's something with high complexity and high churn, you're really beating yourself up. So let's look at how to use churn and complexity together to evaluate your whole code base. And if you saw Ernesto's talk yesterday, this is going to look familiar, but we think that it bears repeating. It's very important. And like Dr. Tannenbaum said, you need to hear things 2 to 4 times. So here we go. All right, to find the areas in your code that need the most attention, you can plot file complexity and churn on a graph like this, using a tool like RubyCritic or Code Climate. But this kind of churn versus complexity chart was first proposed by a guy named Michael Feathers, who is the author of Working Effectively with Legacy Code. Yet another plug for a book you should go read. We use this kind of chart personally to locate areas of our code base that are in need of an intervention. And so to understand it, let's divide it into quadrants and look at each one. This lower left quadrant is the pain-free zone. These files are easy to change and easy to understand. In a healthy application, the majority of your files are going to live here. The upper right quadrant is the painful zone. These files are hard to understand, hard to change, and prone to regressions. Being aware that these files are in this quadrant will help you make decisions about where to add new code. You probably don't want to add more code to these classes. In fact, if you have to touch them, you'd be better off to extract code rather than adding more code to them. This will create simpler classes, the new ones that you extract, that will have a churn score of 1. So they're going to be down in that lower left quadrant. Down in the lower right quadrant are the low complexity files that change frequently. It's possible that these files are actually configuration data masquerading as Ruby code. So for example, there might be some JSON hiding in a .rb file. These files are better served as data files that your Ruby code can read in when it needs it. And finally, in the upper left are the high complexity files that rarely change. Now, these are what Sandy Metz refers to as omega messes. There's what an omega mess is a file that has a big, scary algorithm in it that really never needs to change. And that's Sandy's advice. Don't change it. Leave it alone. It's not causing you any continued pain because there's no churn on the file. And it's so complex that if you were to change it, you'd likely break it. So just leave it alone. Now, these quadrants are really helpful for thinking about this, but in reality, things look more like this. Now, that red line represents the pain threshold. Anything in the pink zone is resistant to change and prone to regression. This file here is in need the most attention. It's super complex, and it's being modified all the time. Extracting hidden abstractions from this class will improve the complexity of your entire application. But there's no need to tackle it all at once. Try improving the code a little bit each time you touch the file. Also, you may not want to start with that particular file. It's super complex and also changing all the time, so maybe you want to start with something down here. This will give you a chance to practice these techniques we've taught you without the pressure of working on your most complex code. So that's it. That's the story of our little coffee machine application, how complexity snuck in, how we recognized it, and how we removed it. Now let's wrap up with a few takeaways and some homework. So here are the 3 things we'd like you to take away. First, complexity will sneak into your application. It happens 1 commit at a time, so be vigilant. Pay particular attention to conditionals that you're introducing into your code. They're often signs of abstractions trying to escape. Also, one of our friends, Josh Clayton, says, don't make your code so dry that it chafes. Second, you can recognize that complexity before it becomes painful. Look at method length, look at complexity, and pay attention to your intuition. If methods are longer than 5 lines, if your flog scores cross 20, or if you just feel like things are getting slower than they used to be, probably time to pause and reflect. Third, you can back away from this complexity. It's totally possible. Leverage polymorphism and factories to enable you to add new features to your application without having to change any existing code. Rehydrate your code or reintroduce some duplication in order to find those missing abstractions that can be pulled out as polymorphic classes. All right, those are the 3 things we want you to take away. These are the 3 things we'd like you to do. First, find out what your average method complexity is using the flog gem. I'm not going to tell you how to do that. You're going to have to figure that out on your own. It's easy. Second, find out which file has the most churn in your application by using the churn gem. Also easy. And then third, find out which class needs the most attention in your application. That's the file with the highest churn and the highest complexity. We bet you probably already know which class this is in your application, but go ahead and confirm it. I see a lot of nodding heads. That's awesome. And then finally, let us know what you find out. Here's how to reach us. Feel free to write, tweet, or reach out via the Slack channel we created for this talk. We'll answer questions there for as long as the Slack channel remains open. Also, if you want to walk your way through the little coffee machine application, you can find it on GitHub at the address at the bottom of the screen. Plus, you can check out other personal projects we have there as well. One of which is a VS Code extension that shows you your flog score for the currently selected text, the method where the cursor is located, or for the entire file, the average method complexity for the file. Just one last thing before we go. As we mentioned, we're from Cisco Meraki. We are the largest Rails shop you've never heard of. We don't build coffee machines, but we do build internet machines for coffee lovers. Both Starbucks and Pete's Coffee are customers of ours. They use our software and our hardware to put their stores and their customers on the internet. So we have a very old, 15-year-old Rails monolith that is over 1.25 million lines of code. It's old, yes. It's super complex, yes. And it handles billions of requests a day and supports a multi-billion-dollar business. If you're interested in solving problems related to complexity, related to software design, or large-scale Rails implementations, come talk to us. We'd love to chat with great Rubyists who are interested in making a change. So that's it. Thank you so much for coming. Here's a list of our references and influences. Go ahead and take a picture. If you have any questions, come find us. Thank you.